Next presentation will be done by IBM team. And as all of you know, IBM is probably the largest and major player in the decision intelligence world. I like the fact that IBM was present at the Decision Camp from the very beginning, and almost every year presented some of advances IBM shows in their tools, and they have all technologies from business rules to optimization tools, especially machine learning tools, and they all usually well integrated. And today we have a very representative team from IBM, including major chief architects of the decision automation products, and I expect to hear very interesting presentation. Pierre, please take over.
Thank you, Jacob. So yes, this topic is about the reasoning capability given by large language models and generative AI, so rational or just predictive. And we would like to have you, let's say, in this journey to understand maybe better what we mean by reasoning and what we can achieve with generative AI or symbolic systems or through hybrid approaches. In this call, we don't have Mariia Berdnyk, but Mariia has participated to the project and including on the benchmark part of this. Super quickly, legal slides about future plans, but right now we are not, let's say, communicating about product future plans, so we are good. So in the agenda of this presentation, so do large language models reason? And I believe that this is, let's say, one key question today with large language model, large reasoning models, and let's say benchmarkings and news that we get, let's say, every week. A kind of, let's say, landscape of this benchmarks as of today. And some proposals or observations about mixing generative AI with the symbolic engines to have, let's say, good reasoning and reasoning that we can apply to operational decisions for enterprises. And last, so a call to action about, let's say, benchmarking for operational decision making for enterprises. Okay, so let's start directly in the topic. So do LLMs truly reason or just simulate reasoning via statistical patterns? And this is the kind of key question that we have faced since, I would say, the start of ChatGPT. In November 2022, and even before, with, let's say, previous version of generative models. And we have seen, let's say, since about 3 years, an evolution in the technology. So at the core, the large language models are deep learning models, and they are auto-regressive models. And they benefit from reinforcement learning with human feedbacks to correct, say, their predictions, their generations of tokens. And on the top of their, let's say, statistical core nature, so we have seen prompt engineering, so the art of prompting to get the generations that you were expecting, or something that brings value, let's say, in your activity. We have seen RAG pattern to exploit, let's say, a large corpus of documents or information, and to have, let's say, significant generation based on this corpus. We have seen, let's say, from the very start, or let's say rather quickly, the opportunities given by the fine-tuning. But quickly, the fine-tuning, let's say, was limited by the amount of GPUs that were, let's say, available. And by the price of this, let's say, hardware plus the skill set and the energy or the time that you have to allocate to improve this large language models. And the self-verification, this is another, let's say, ingredient. So a lot of technologies that we see and with a quick evolution. And in the, let's say, past year, maybe more, we have seen, let's say, an acceleration in the rising of reasoning models. So we have seen the DeepSeek R1, we have seen one and the others. So every, let's say, providers of large language models, including IBM, claim to have reasoning models in their catalog. So let's start by the definition of reasoning, and this is a kind of a difficult, let's say, exercise. As let's define together. Let's convert on a unique definition of AI. But what is reasoning? So if we take Britannica dictionary, so the process of thinking about something in a logical way in order to form a conclusion or judgment. And if we look at Cambridge dictionary, the process of thinking about something in order to make a decision. So thinking, you see, let's say, the subsequent definition on the same slide as well. So we are using the mind to produce ideas, decisions, memories, and or to consider something. The big difference between these two definitions is that the left definition precise that it goes through logic, and the Cambridge definition, let's say, doesn't mention logic. So after maybe in the mind, or let's say in other, let's say, activity, in other definitions in the ontology, we could find logic, but directly on the reasoning definition for Cambridge, the Cambridge dictionary, we don't find it. And I think that in most of the discussions, this is the kind of nexus. So do we expect a kind of guarantee of logic in this reasoning to go from, let's say, some information, some input information, the context, let's say, facts, to reach conclusions or to produce, let's say, other information that we will add in this context. And this is the big question. So do we proceed through logic, or do we proceed with, let's say, other means, including statistical means, to have this mind activity? So let's continue on the reasoning types, because I believe that we could, let's say, have a misunderstanding of, let's say, what is the kind of reasoning that we do usually with some technologies. So the first, that is let's say, maybe the most common, is the deductive reasoning type. So we are drawing specific conclusions from general principles. So this is what we do when we do physics. We apply, let's say, rules of physics, or when we are doing mathematics, coming, let's say, with some data, and we are applying, let's say, theorems and so on. We can see a very simple example: all birds can fly, a robin is a bird. But on this very example, we can feel that we need exceptions. And as we know, exception handling is, let's say, a big part of let's say, the decision modeling. We don't need only, let's say, the general rules or the general laws, but we need, let's say, to model as well all the exceptions that do a difference. So for this, for the deductive reasoning, rule-based systems, they are good at, let's say, this. We see, let's say, a lot of deduction in law and, let's say, many, let's say, businesses. We proceed with, let's say, through deduction. Inductive, so we are making generalization from specific observations, and this is what we do usually through machine learning. And so from a data set or the samples, we draw a kind of generalization. So every swan I have seen is white. So I can suppose that all swans in the universe are white. Abductive, so this is less common. Let's say the name is less common. So So for me, this is the kind of Sherlock Holmes, let's say, mode, let's say, a reasoning mode. So inferring the most likely explainable for observations. So the ground is is wet. It probably rains. So we are mixing, let's say, logic or let's say causal inference with the probabilities. And this one is, let's say, we use it every day, I believe. And there is a mix, yes, between certainty and uncertain, let's say, information. So I believe that this is very common in diagnostic systems and in other areas. And analogical, so we transpose some kind of concepts or articulations between concepts to identify similarities between situations. So you see the example there, pumps blood like a water pump. So we find analogies, we find similarities, and there is a kind of meta-knowledge or meta-rules to say, okay, if we have an understanding or say a description of a domain that works, can we transpose this understanding to another domain to solve a new problem? In addition to this, I would say most dominant or most common reasoning types, today you can see other, let's say, reasoning types. So with the trend, you can see agentic reasoning with a kind of workflow or say a flow of distribution or orchestration of agents, and after the agent are doing something based on just LLM or through a delegation to tools. So this is more about technologies and the kind of, let's say, principle of specific reasoning. You can hear about common sense reasoning as well, fuzzy, with fuzzy reasoning, fuzzy logic. We can hear about hybrid or neurosymbolic reasoning. And after, when you are introducing some probabilities in some form of reasoning, so you can have a probabilistic reasoning, spatial reasoning, temporal reasoning, and you can mix spatial and temporal reasoning dimensions with the other dimensions that you see in the table. So in conclusion, several types of reasoning, and all technology are not good at, let's say, conducting all these types of reasonings. So reasoning in AI, and I reused one public page of IBM, and I think that it's interesting because it illustrates a kind of tension or between two approaches. So what you see here is mainly, I would say, a symbolic AI definition. So reasoning in AI may be depicted as a system made of two core components, a knowledge base and inference engine. And so I like this definition. It makes sense with expert systems and production systems, BRMS, and with a separation between the knowledge base, so that captures this knowledge of the world, and after we deal with an inference engine that will go from let's say context and say use this knowledge base with the rules, and the rules will let's say capture the logic to infer and to construct, let's say, an outcome from the information that we have in the context. But starting, let's say, from this definition, and then looking at the LLMs, so can we consider that outside of the pure knowledge graph and the knowledge, let's say, layer, can we consider that the latent space where we have tensors in the large language models and in deep learning in general? So can we consider these latent spaces as knowledge graphs and as knowledge base? And we know that it compresses information, but can we qualify this latent spaces as a knowledge basis? And this is a question I don't have, let's say, an answer for this one. It would be, let's say, a topic for debate. And when we see the inference for rule-based, let's say, approach, we see inference as well that is mentioned in machine learning models and chain of thought in large language models. But do they behave the same, let's say, on the same principles? And I believe no. And let's continue in this presentation. So reasoning in AI, and let's zoom out a little bit. So symbolic AI, so we usually have this dichotomy between knowledge base and inference engine, inference algorithm like RETI. And we capture the knowledge, let's say, of the reasoning. So what are the laws, or how we go, let's say, from input information to the final outcome or intermediate outcome by modeling this knowledge, this expertise through if-then else decision tables rules. And these assets are made, let's say, are part of a declarative programming language. And we chain these rules or instances of the rules through, let's say, two different directions. So the forward chaining, and we are starting from the known facts to infer new conclusions. And the backward chaining that aims to prove an hypothesis by applying rules on facts. This is a reverse. In the past, like in neuron data many years ago, there was even, let's say, a kind of mix algorithm to decide if we were backward or forward during one decision making. Neural AI. So neural AI is very good at pattern recognition, and so there is let's say, an open question on the reasoning or simulation of the reasoning, and we have seen, let's say, I think all in this call the limits rather quickly of the reasoning capability given one prompt. In calculus, let's say simple mathematics, or let's say logical reasoning, and at some point the answer, let's say, that was made is that okay, one prompt is not enough, and let's jump to the chain of prompt, and RAG was at some point an answer as well to say okay, with this let's say new techniques, we will let's say have better results in the reasoning. And I believe that this is the case. So the decomposition of a problem and the, let's say, how to solve this problem improve, let's say, the reasoning capability, but does the LLM or large reasoning model works based on logic? This is something that, let's say, remains, let's say, as a question or a source of debate, and answer will let's say, will depend on the, let's say, what is the LLMs that we are working on, and what are the mechanisms, and we will see after typically the delegation to tools or code generation that can change the game for the large language models and the large reasoning models. And in addition, so what we are doing, let's say, for years, and with clients in fraud detection and in other, let's say, domains, is that we are mixing different types of AI. So I believe that there is an opportunity to get the best of each of the AI technology. Symbolic neural, let's say, AI with, let's say, machine learning to get predictions of risk or opportunities, and generative capabilities, typically to extract information or to process language. But for the reasoning, I would keep my preference so far for a logic engine, and I will detail, say, more this point of view in the next slides. So if you look at the reasoning benchmarks in this domain, there is, let's say, quite a lot of them. But after there is a difficulty, honestly, in deciphering, let's say, what is the mission of each of the benchmark. And if you have a project and to automate, for example, the claim processing for Medicare or for fraud detection in a payment, let's say, platform, or let's say some very, let's say, applied use cases, and you are asked to what extent you should use or not an LLM, it will be, let's say, very hard to identify the benchmark that would be helpful to drive your decision. So yes, there are benchmarks, but after when coming to operational decision management, I believe that they are, let's say, missing information, or we don't have, or I have not seen so far benchmarks that were, let's say, very applied to this domain of operational decision management. On the reasoning capability of the LLMs and LRMs, so you may have already seen this valuable paper published by Apple Research in June. And this is titled The Illusion of Thinking. And they have benchmarked a set of large language models or reasoning models, and on the 4 puzzles. So one being the Hanoi Tower game, but they have, let's say, used 3 other games as well. And they are playing these games with the generative AI engines, and they are paying attention, or say measuring the outcome, the performance of the outcome. So is the solution, they say, okay or not? But they are tracking as well, say, the moves in the game for each of them. So they have, say, put in place a kind of fully controlled puzzle environment, and they are testing with different level of complexities, and they have identified 3 levels, so small, medium, and large complexity for these 3 games. So what are the key findings? So when playing with this 4 games with a panel of LLMs and LRMs, they see that with small complexity, and so the criteria, let's say, as they differ per game. But for example, for the Tower of Hanoi, it will be with a number of, let's say, layers in the tower. They observe that there is a significant drop of accuracy, so for the outcome for the solution, when this complexity, with this complexity, let's say, goes up. And you see, so depending the number of disk for the tower, it goes, let's say, to 0, starting at 10 disk. And whatever, let's say, is the large language model or reasoning model that you see at the bottom of the slide. And you see, let's say, the same trend when the complexity raises, whatever is the challenge. So let's say the outcome is that the performance, the accuracy, let's say, is not linear at all, depending on the complexity. So this is not a big surprise, but it can be, let's say, down to 0 depending on the game. The second finding, and was much more surprising, is that there is a kind of laziness of the large model to reason about the game when the complexity grows. And what you can see in the thinking tokens is that the thinking tokens, let's say, goes down when the complexity is let's say goes up, and this is totally counterintuitive. You could let's say consider or suppose that it would be let's say up as well with the complexity, but in fact it abandoned, and this number of thinking tokens goes down when the complexity goes up. And we can, let's say, reasonably let's say think that it may not be a good let's say a way to solve high complexity problems if you are thinking less. I would say that as a human, this is counterintuitive. So in this research, let's say there are good say findings, or let's say good practices. So the fact that they have introduced a kind of gym environment, control puzzle environments, and they are looking at the input, the outcomes, and the track. So how the game is solved by the reasoning, or the supposed to be a reasoning model. They have analyzed a three-phase breakdown depending on the complexity, and this is something that could make sense in the operational decision management benchmarks as well. And the fact that the LLM give up when facing to, let's say, high complexity was a surprise. But after, so outside of the Hanoi Tower game, so when we are looking back to claim processing, loan approval, and so on, we could say that we can generalize, let's say, these findings or not. And my point is that we need to have benchmarks for operational decision management for real business use cases. So let's continue in the operational decision management piece. So what we do usually at IBM, I think it's larger in this community, is that we automate business policies, and what we usually, let's say, perform is we are helping organizations to automate their policies. They can come from regulations, or they can come, let's say, from let's say good practices, or let's say principles that are private to this organization. But in all cases, there is a business policy that is a written statement expressed in natural language. We can have tables, schemas, and so it can be, and most of the time this is regulated. It can change, meaning that we have to take care about the maintenance and the evolution of the automation, given, let's say, an evolution of the regulations. And based on this business policy, we are supporting, or we are processing a decision request. Is, let's say, the client eligible to this loan given this application, and given my policy to accept or reject a loan during this quarter. So organizations are looking for the best solution, or what technology, what methodology do they have to put in place to have a good, let's say, IT solution that will match the business policy and all the regulated aspects. And it has to be accurate. It has to be compliant with the regulation. Usually, it has to be explainable, real time, or real time enough, secure, and the cost has to be competitive compared to alternate solutions. And at the end, so given this IT implementation, we have a decision response for any decision request that we inject in the system. So if we take the hypothesis of using LLMs, or large reasoning models, so we continue on this picture, and we are using in the middle a large language model. You can use prompts, RAG, chain of thought, and the big, let's say, advantage is in coding very little in the, let's say, in this solution, because you just have to make the, let's say, the integration to get the request, invoke one prompt, or say one, let's say in one call your LLM, or start a chain of thought with several prompts, and so with luck, you may have the right decision given the policy. So the policy, you can have it in the prompt, or you can have a RAG or a vectorization of the given the business policy in your prompt. And you expect, let's say, to have good answers with, let's say, explainability, accuracy, let's say, all the criteria that I mentioned before. The issue today is that you don't have a reliability in the accuracy. You may have hallucinations. Even, let's say, with the same request, you have no guarantee to have the same answer. So lack of determinism. The justification, so some of the reasoning models give you an explanation or a kind of chain of thought to justify, yes, how the decision was made. But in some cases, what I see is a kind of another generation that imagine what has been, let's say, the reasoning path, or the supposed to be reasoning path. But this is, let's say, something that has been generated post hoc, and this is not a kind of trace of a logic engine that was triggered to make the decision. High latency. So for IT integration, the latency, let's say, is much higher with this technology compared to rule engines or, let's say, regular code. And the execution cost in tokens, it can be, let's say, much more compared to, let's say, classical IT integration and coding. So let's move on and consider that the LLMs, so they are not good enough to take, say, to make enterprise decisions with all the criteria that we need. And the idea is to delegate this reasoning from the LLM to a tool. And as let's say, mentioned just before this talk, so there is a protocol named MCP that is now, let's say, a kind of industry standard to declare a tool, and that can be an implementation of any REST API or other, let's say, function. And you can call out this tool from the LLM when there is a detection of an intent. And typically for to approve or reject a loan application, you would say, okay, I declare a tool to approve a loan. And when the LLM will detect that there is a context or there is an intent to approve this loan, it will capture all the information from the conversation and call out your tool. And in this tool, you can have any programming that you, let's say, prefer, Python, Java, whatever, to make, let's say, this decision. So the idea is that you can have a kind of mix between the natural language processing by the LLM and the reasoning that you delegate to a program that is acting outside of the LLM, but there is a nice integration between the two thanks to MCP. I go quick. So if I recap, in this solution, you have your business policy, you to ground your request, you have made a decision tool. So it can be in Python or any any solution. And by using this approach, you, let's say, decrease the risk of bad reasoning made internally by the LLM, as you control totally the reasoning automation that you have in your tool. Okay. So you can be deterministic, you can have the accuracy, let's say, depending on the investment that you do and your technical choices that you do to implement this tool. And the LLM, let's say, is there to have the natural language processing and the detection of the intent, but not the reasoning. So in the panel of the solutions to implement a reasoning tool, you can use Python or Java or any language, but you can too consider a rule inference engine and declarative rules to capture your expertise and have, let's say, all the logic of your regulated policy in a rule set. And like this, you can have a rule flow or, let's say, a decision model notation flow in which you describe, let's say, how the reasoning is done, and it gives, let's say, advantages, including for the collaboration between business users and developers to formalize this logic. And the idea is to separate the logic from the control, have a good decomposition of your reasoning flow. And this is something that where you deal with symbols, with knowledge, and you can check with a business analyst if it's okay or not, while with neural network. And based on tensors, the validation is much harder. The rules are good at doing efficient pattern matching, and for we get the trace. So we have an explanation, let's say, by definition, when you run the rule inference engine, and in addition, we have technologies to write rules in a domain-specific language and in different locales. So it can be Japanese or French or English. There are technologies to adapt to a specific language. So if we are selecting this, let's say, delegation from the LLM to a rule engine, the idea is to once again delegate the reasoning part from the LLM to the reasoning tool, and have a transparent reasoning, the determinism, and the maintenance that is easier because now you are using a declarative programming method. And you can share, let's say, with the business user what is the model when there is a V2 of the policy to take into account compared to a V1. So I will go quick, but there are, let's say, qualities there are to adopt a rule inference, let's say, tool in this picture. In all cases, so there is a cost to capture the knowledge, and whatever, let's say, is the implementation language that we select, we have to formalize, we have to ask questions, we have to make sure that we have covered enough. Let's say the decision making in the head of the expert. We have to understand what are the exception, the edge cases, and it means, let's say, that we spent enough time and energy and investment to capture this knowledge. But in, let's say, another opportunities given by GenAI today is that we can use large language models to extract rules from the policy. And this is something that we have done at IBM. I will not present this topic in this slide, but extraction of data model and business rules from policy text is now made possible thanks to generative AI. But the idea is to use generative AI for let's say, the natural language processing, and after have a human validation of the logic that we have extracted from the policy, but not rely on the LLM for the reasoning on a kind of, let's say, supposed to be good logic, but without any guarantee. So last piece is the benchmarking of enterprise decision automations. And so far, yes, I have not seen, let's say, ready to use benchmark in this operational decision management landscape. And what clients usually, let's say, are looking for, they are looking for decisions where they see determinism, precision as well, and especially when we are dealing with regulations, if we are not precise enough and we have a, let's say, penalty or a fee, it can be, let's say, very impactful for the organization. The precision, kind of, let's say, global remark here. Usually, I see, let's say, high accuracy in some machine learning models or even generations made by LLMs. But if we miss only 1%, but this 1%, for example, in fraud transaction, fraud detection on transactions is on the, let's say, highest amount transactions, the business impact will not be the same as if, let's say, this 1% of, let's say, misclassification is done on the, let's say, one low part of for the amount of the transaction. So my point is that the pure statistical metrics may not be enough to judge with a business angle what is the performance of technology to automate the decisions. And we have to make sure, so when we have an implementation, that we cover, let's say, all the code, and that the policy is well covered as well. So if we have a benchmark and we compare, let's say, two solutions, but if the coverage of the policy is not the same, then let's say this is not a kind of fair comparison. So there are kind of business and technical aspects to be considered to have, let's say, a good benchmark for this kind of decision-making automation. Response time, scalability, modeling and governance cost, and the operating costs. So there are criteria as well that do a difference in the adoption of the technology by the organization, and they should be reflected somewhere. So quickly, what we have worked on for us several years is say a kind of evaluation of a policy-based decision making. And the idea is to incrementally, let's say, develop this kind of benchmark framework. And the principle is that let's take any business policy, can be loan approval or let's say whatever is, let's say, whatever topic. And from a business policy that is expressed in natural language, we develop manually, or we can have the help of a generative AI as well. But at the end, we have a human validation, and we know that the code, let's say, respects fully the policy. And so we have this open source reference decision runner, or say decision maker, that implements this policy. We are doing, or we can once again have the help of generative AI to generate a data set. And we are running this decision runner on this input data set to have a decision response data set. And this input and output data sets will be the reference data sets for the benchmark. And after, when we want to judge about the reasoning capability, the decision automation capability of any technology, we can run the let's say this let's say a new solution, and we will compare the outcomes with the reference outcomes. And in addition, so it's not mentioned here, but we could compare as well the reasoning trace when it makes sense to judge about, let's say, the quality of and the performance of the reasoning. So we have started this policy corpus and a framework that has been developed by Mariia and some others in the IBM team. So this is open source, and we started to have a kind of a catalog of business decision automations and across the different domains. And for each of them, we want to have a synthetic policy, okay? So for banking, for detection, something that may not be, let's say, super long, but something that is, let's say, reasonable enough. The reference input data set, reference implementation, it can be just a piece of Python or anything that we can run, let's say, easily. And with a non-proprietary, let's say, implementation solution. And we can run this implementation on the reference inputs and have the outcomes. And we should commit as well the reference outcomes for more ease of use on the GitHub. And after, we can have an evaluation code that is custom to measure, let's say, the distance between test and reference decision automata. And we have already, let's say, a test that is a code that is generic to make this comparison, and kind of plug and play framework and to add new benchmarks. So this is, I would not pretend that this is already, let's say, perfect and complete, but this is something, let's say, that I would like to develop during this 2H and next year. And we are collaborating with the Université Paris-Saclay, with the Central Supélec School, and I am starting a new phase of collaboration next week. So as a wrap up, so today, what I have seen in my experience and let's say grounded on this Apple research paper is that we see observable limits in the reasoning of the large language models and as called large reasoning models. And basically, my understanding is that this is due to their stochastic nature. After, we know that this field is evolving super quick. And so they can delegate to tools. They can generate on the fly code. And if you look at, for example, OpenAI, you see very often that it generates a piece of Python to answer to your question. And so it can, say, overcome some of the limitations that you may have if you just follow the neural network at the core of the LLM. But so far, they are not logic engines, as we can deal with logic with, let's say, rule management systems. Trust and accountability, so they remain, let's say, paramount in regulated businesses. And I think that as long as there is no enough guarantee in the reasoning given by LLMs, we will struggle, let's say, in the adoption of LLMs on this task. And I would much prefer to have a kind of pragmatic approach, mixing different technologies, and have the LLMs for processing the language and for the understanding and generation of text, and have a delegation for the reasoning for specific, let's say, engines, typically rule inference engines, optimization engines, whatever, but something that is grounded on logic and where we control, let's say, how the reasoning is done, and engines that give full trace and transparency. So next step is we will continue on the benchmark effort, and if there are participants of DecisionCamp who wants to contribute or wants to discuss about this, please contact me and Guilhem, and the contributions are welcome to expand these benchmarks and make evolutions in the tooling. Few links. So you have links about LLM benchmarks at IBM, reasoning models, and so forth. So I just let this slide, and this is it. So thanks for your attention, and open to any questions.
Okay, thank you, Pierre. Very, very interesting and specific presentation. We have time for questions. Anybody? Just unmute yourself and ask question. There is a question in chat from Tom. Tom, you can talk.
Okay, so I have a number of issues with your claim that the large language models will hallucinate. That's kind of a red herring, right? It's entirely possible to write prompts. People do it all the time that don't hallucinate. Okay, so and next you kind of mentioned that you dismissed the thinking claims or the reasoning claims of the models without evidence. You just said, I didn't like them, all right? The new ones, the large language models that you mentioned, Gemini 2.0 and ChatGPT 1.0, there's been a lot of advances in that. And from my experience, it's entirely possible to do most of what you can put into a rule-based model, with a certain set of exceptions, right? And get a well-reasoned explanation why it executed. So I'm not buying. I think that the basic issue right now is cost. It's very expensive to have the large language models running rule-based logic, but definitely is, places for that. So I'll allow you to respond to those questions.
Yeah. So thanks for the or let's say comments and questions. So let's start by let's say where we tend to agree. So on the cost. So the cost is let's say can be significant depending on the models that you choose, and if you are using Mistral Large or let's say other or Llama 3 or 4, the cost per token will not be the same. There is another element that is the latency. And if you are looking for, let's say, real-time integrations and in milliseconds, so reasoning or say any processing with an LLM can be, let's say, a problem because it will be more in seconds than in milliseconds. Yeah. Whatever we are using, let's say, local processing or for very large, let's say, models, you have to do a remote call and you have to go through, let's say, internet for this, and with the cost, security, and network. On the yes. On the gap, I agree that the evolution of the large language models and reasoning models is super fast. And it was super, let's say, easy to, let's say, have bad answers or hallucinations 3 years ago, and now it's much harder. And let's say statistically, you have much more, let's say, better result today with the latest version of these models. And the gap or the kind of advantage between the technology tend to, let's say, to reduce. But how could I explain it? So to me, there is a kind of asymptote, or it's if I take the example of autonomous car, for example, let's say the car makers and technology makers were, say, promising a future of autonomous cars in our streets. 5 years ago, something like this, Tesla were promising, let's say, highest level of autonomy, and I believe that let's say the challenge, even if we did progress, it has been harder than, let's say, planned, and even if we have multiplied, say, the resources, we piled up, let's say, the investment, there are some capabilities that are very, let's say, hard to reach. And I believe that have a kind of sound and perfect reasoning through LLM or, let's say, reasoning models, we will have a kind of tangent, but without, let's say, a logical behavior at the core, we will miss the point. But I may be wrong.
Yeah, again, I agree entirely. Like, yeah, you don't want to be pumping a prompt into your, again, yeah, I support the idea of an integration between the symbolic and the sub-symbolic AI. You don't want to have a prompt, it's too expensive, it's to be running, the time consumed and so forth. But what I would maintain is that the ability to reliably execute logic defined in a prompt and connected into your symbolic process model opens up an entirely new set of applications because you can create levels of extraction that were not available before. So, and we'll talk about, but they're at this point, it's too expensive to run them, in milliseconds, thousands of times a second and so forth. So it would be more of higher level types of logic like policies, contracting policies, and so forth. Okay, that's all. Thank you.
Welcome. And yes, go ahead.
Okay, just you asked at the very beginning a question, large reasoning models, do LLMs truly reason or just simulate reasoning? May I summarize that your answer is they don't reason, and Tom is more on another side. Right?
Yeah, but I would say, okay, the answer that, let's say, depends on the text, on the definition that we retain. And if we, let's say, retain that reasoning, let's say, needs logic, I would say that right now, if there is no kind of strict delegation to the reasoning to a logic engine, it simulates this reasoning. But after, so so based on recent talks with an IBM researcher, for him, it was, let's say, obvious that reasoning could happen in a large language model, even without logic. And I think that there is a kind of, let's say, debate or tension. Do we suppose to have logic in this reasoning, or can we produce, let's say, meaningful and, let's say, valuable outcomes without having, let's say, this kind of mechanical, logical engine?
I think I would say I don't care, right? I want to know that the result is dependable, repeatable, and scalable, right? Whether it's reasoning or because in AI, most of the time we said that reasoning is the manipulation of symbols to reach a conclusion, right? That's the AI model or the IT model. Reasoning, when it starts to bring human in there, you get into like subjective experience, right? And so I don't think we're at a level where we're going to have subjective experience except provided by humans into the decisions, right? So I really don't care. We just want it dependable, repeatable, secure, and all of the good stuff we need in information technology.
Okay, because we running out of time. What is a good thing that these two opinions represent different movements in decision intelligence in general, and it's good. And I'm sure even our next presenter probably will contribute a lot in this discussion. And again, Pierre, thank you very much, and we will continue to ask questions about this. Thank you.
Thank you.
Okay.